The wind moves first, long before any city rises, long before any wall is built to stop it. It comes down from the ice and crosses an open land where grass bends flat beneath it, and ancient bones weather under a pale sky. There are no temples here, no farms, no roads, no written laws, no maps with borders. There is only a world that keeps changing, and people who must learn to change with it, or disappear into the silence that covers almost everything before history begins. Somewhere in this vast age, a human group moves along a valley edge. They're not the first humans, and they are not alone. Other kinds of humans live in other valleys, on other plains, in forests, in caves, along rivers that will one day be buried, dried, flooded, or renamed. Their world is older than memory, but it is not empty. Across Africa, Europe, and Asia, different human populations carry different bodies, inherited strengths, local knowledge, and ways of reading the land. Some are ancestors of living people, some are close cousins, some are lines that will vanish so completely that, for tens of thousands of years, no one will even know they existed. This is the forgotten age before civilization, a span so large that the mind has difficulty holding it. 100,000 years is not a pause before the real story begins. It is longer than the distance between the first pyramids and the present many times over. It is long enough for coastlines to move, deserts to turn greener and then dry again, ice sheets to advance and retreat, animal worlds to rearrange themselves, and human populations to meet, merge, separate, and fade. Yet because these people left no chronicles, no royal tomb lists, and no cities with streets still visible from above, they're often treated as an opening shadow. That is a mistake. The evidence remains incomplete, but what survives suggests remarkable endurance. Before we go deeper, take a moment to like the video and subscribe. If this is the kind of history and mystery you enjoy, then let the modern room fall away, because the place ahead is older than almost every story humans have told about themselves. The ages usually approach through its artifacts: a blade of stone, a burned patch of earth, a cracked bone, a tooth, a flake from a toolmaker's hand. These things look small in a museum case, but each belongs to a chain of decisions. A tool begins with the choice of the right stone, one that breaks with the useful edge. It requires knowledge of where to find it, how to strike it, how to repair it, and how to teach the gesture without writing it down. Yet most of what these humans knew was made of materials that rot, burn, soak, or vanish: wood, fibre, hides, shelters, pigments, traps, cords, and soft tools for ordinary tasks almost all disappear unless conditions are unusually kind. So when later people ask why humans appeared to stay unchanged for so long, part of the answer is that the record is unfair. It preserves stone and bone. It rarely preserves thought, language, gesture, song, memory, or the quiet habits that make survival possible. Still, the land keeps traces. Around 100,000 years ago, the Earth is in the late Pleistocene, a time of unstable climate and dramatic swings. Ice grows in the north, then retreats. Sea levels fall as water locks into glaciers, exposing continental shelves that are now drowned beneath shallow seas. Forests expand, then shrink. Grasslands open. Lakes appear in basins that later become dry. In Africa, groups of Homo sapiens live through changing habitats. In Western Eurasia, Neanderthals endure cold and temperate cycles with bodies powerfully adapted to their worlds. Farther east, across the huge spaces of Asia, another human lineage exists, still almost invisible to us, leaving so few bones that for most of modern science it goes unnamed. These are the Denisovans, though not by that name. Their identity will come from something smaller than a sentence molecules hidden in ancient remains. But before the cave and before the genetic revelation, there is the world itself. It is not a simple Ice Age postcard of endless snow. The Pleistocene contains cold steppe, wooded refuges, river valleys, mountain corridors, monsoon landscapes, coasts rich with shellfish, and high plateaus of thin air. Mammoths graze in open country. Wild horses travel in herds. Deer, bison, rhinoceroses, goats, and predators follow the opportunities of season and terrain. The human groups among them cannot rely on a single way of life. Survival is local, knowledge is local. A valley, a river bend, a patch of useful plants, a safe overhang, a reliable stone source, these details matter more than any grand idea of progress. This is one of the quieter surprises of the forgotten age. These people are not waiting for agriculture. They are experts in a world that later farmers would often find terrifyingly uncertain. To live without stored grain, metal, towns, or written instructions is not to live without intelligence. It is to depend on forms of intelligence that leave fewer monuments. A hunter must understand wind, tracks, animal behavior, season, patience, risk, and cooperation. A gatherer must know which plants feed, heal, poison, or return only after rain. Scholars still debate how complex these societies were in any given region, and the answer probably varied widely. The age also resists a single human story. Modern people tend to imagine one straight line ape to human, cave to village, village to city, city to civilization. The real pattern is more braided and stranger. Human evolution is not a ladder, it is a thicket, full of side branches, crossings, lost paths, and hidden survivals. By the time Homo sapiens begins spreading widely beyond Africa, other human populations have already adapted to their own worlds. Neanderthals are not failed versions of us. Denisovans are not a footnote. Other archaic groups may have existed with names not yet assigned. No single explanation fully accounts for the pattern. It is a long sequence of contacts, separations, environmental pressures, demographic accidents, and choices made by small groups under conditions we can only partly reconstruct. And all of this happens before civilization. If civilization means cities, states, bureaucracies, monumental architecture, and writing, the absence of cities does not mean the absence of history. It means history is carried differently in memory. Roots, tool traditions, hearths, pigments left on stone, and genes carried forward by descendants who may never know the names of those who gave them. Popular imagination sometimes wonders whether a complex civilization could have risen in this deep age and vanished without trace. But mainstream archaeology is cautious for good reason. Cities, metallurgy, and dense urban life leave many signals. So far, the evidence does not support a lost industrial or urban civilization hidden in the Pleistocene. The mystery is subtler. The people before civilization did not need to be secret kings of vanished empires to matter. Their achievement was survival itself, repeated across impossible time. The forgotten age is therefore not a blank before the dawn. It asks how much can vanish while still shaping the future, and how many humankinds once shared the planet before disappearing without a face. Somewhere in the mountains of Asia, in a cave visited by animals and humans across immense spans of time. One of those lost presences will eventually come back to light, not as a city under sand, and not as a legend carved into stone, it will return as a small piece of bone, almost too ordinary to notice, carrying within it the proof that the human past was wider, stranger, and more crowded than anyone had imagined. The fragment that changes the story does not look like the beginning of a revolution. It is small, pale, and easy to underestimate, the sort of object that could rest in a tray among many other pieces from an archaeological excavation and seem almost silent. Yet this is often how the deepest parts of the human past return, not as a golden mask, not as a palace wall, not as a city gate rising from the dust, but as something nearly weightless, a piece of bone, a tooth, a trace of protein, a few molecules protected from time by cold stone and chance. The place is Denisova Cave, set in the Altai Mountains of southern Siberia, where Russia, Kazakhstan, Mongolia, and China lie within the wider geography of Inner Asia. The cave opens into a landscape that has long acted as a corridor, a refuge, and a meeting ground. Mountains rise around it, valleys cut paths through them, forests, steppe, and river systems shift with climate, offering shelter in some periods and hardship in others, for animals and humans moving through this region. The cave is not a symbolic landmark in the later sense. It is practical. It offers cover, a place to pause, perhaps a repeated point in a remembered landscape. Over many thousands of years, different beings enter it, leave remains behind, and move on. The cave becomes a kind of slow archive, not written by any hand, but layered by occupation, weather, sediment, bone, ash, and time. Archaeologists had worked there for years before the name Denisovan meant anything in human origins. The cave had already yielded stone tools and remains that spoke of deep activity. It was clearly important, but importance in archaeology can hide in plain sight. A site may be rich for decades before one small sample forces an entirely new interpretation. The excavation layers held evidence from different periods, and the difficulty was not simply finding objects. It was understanding who had made them, who had used the cave, and how many kinds of humans had passed through the same sheltered space. In the Pleistocene, a cave could be shared across ages by species that never met there at the same moment, or perhaps sometimes did. The evidence remains incomplete, and the cave does not offer its story in a clean order. Then ancient DNA changed the scale of the question. For much of the history of paleoanthropology, bones-shaped identity, a skull, a jaw, a pelvis, a limb. These were the things scientists compared. They measured brow ridges, teeth, cranial shapes, limb proportions. They placed fossils within branching human family trees using anatomy. This method remains essential, but it depends on having enough anatomy to read. Denisova Cave offered something more difficult and more powerful. It offered fragments too small to define by shape alone, yet still carrying genetic information. In one of them, preserved inside ancient tissue, was a genome unlike that of modern humans and unlike that of Neanderthals, though related to both. The first famous clue was a tiny finger bone from a young ancient individual. By itself, it did not announce a new human population. It was not a complete skeleton lying in dramatic posture. It did not provide a face, height, walk, or gesture. If judged only by appearance, it could not have carried the weight later placed upon it. But inside it remained mitochondrial DNA, and later nuclear DNA, and those molecules told a story that the bone's shape could not. The sequence was not modern human. It was not Neanderthal in the expected way. It belonged to a sister lineage, a population that had split from the ancestors of Neanderthals long before, and then followed its own path through Asia. This is where the mystery becomes unusually modern. The Denisovans were discovered not because someone found a grand fossil and named it by its skull, but because genetic evidence revealed the presence of a lost people. They were, in a sense, a human group found first in code. Their name came from the cave, not from a region they ruled or a culture they wrote down. They did not introduce themselves through monuments. They emerged because science had learned to read the fragile chemical remnants left behind in old bone. It is hard to overstate how strange this was. A major branch of humanity had existed across deep time, had interacted with other humans, had left genetic descendants, and yet had remained nearly invisible because its bones had barely survived. Denisova Cave then became more than a site. It became a warning against overconfidence. For a long time, the known human past had seemed crowded enough with Homo sapiens, Neanderthals, Homo erectus, and other fossil groups. But the Denisovan discovery showed that the map was still missing entire populations. If one unknown human lineage could be found from a small fragment in Siberia, then other lost groups might also have lived and vanished with only faint traces left behind. Scholars still debate how many archaic human populations existed across Asia during the late Pleistocene, and how many of them interbred with one another. The old family tree begins to look less like a tree and more like a river delta, with channels splitting, rejoining, and disappearing under sediment. The cave also complicates any simple idea of territory. Over time, evidence from Denisova Cave points not to one neat occupation, but to repeated use by different humans, including Neanderthals and Denisovans. In later research, even the sediments themselves become important, because DNA can survive in the ground without a visible bone attached. This is one of the lesser-known revolutions in the story a cave floor can contain genetic traces, as if the walls and dust have kept a breath of vanished populations. Such evidence must be handled carefully, because contamination, dating, and layer disturbance can complicate interpretation. But when properly analysed, it widens the record beyond the rare fossil. It allows scientists to detect presence where anatomy is absent. There is something almost haunting about that. The cave keeps the memory of beings who entered, rested, worked, perhaps warmed themselves near fire, and left almost nothing that the eye can recognise. Their tools may not always be easy to assign. Their bones are scarce. Their bodies are mostly unknown. Yet their DNA remains clear enough to say they were here. They belong to the human story. They were not imaginary, not legend, not a popular theory waiting for evidence. They were a real population, close enough to us to leave descendants, distant enough to remind us how many forms humanity once took. And Denisova Cave does not stand alone in meaning, even if it stands at the beginning of the name. Once the genetic signal is recognized, researchers begin looking for Denisovan traces elsewhere in modern genomes, in fossils from other regions, in high-altitude adaptations, in teeth and jaws that might once have been impossible to place. The cave becomes a keyhole, not the whole room. Through it, the forgotten age opens wider. A tiny bone from a mountain cave reveals that before civilization, before farming, before the first cities, human survival was already a story of multiple peoples moving through the same planet, sometimes apart, sometimes together, and sometimes close enough that their inheritance still moves quietly inside living bodies today. What follows from the cave is not a full portrait, but a puzzle built from almost nothing. The Denisovans enter science as a presence before they become an image. They are known with unusual genetic clarity and almost embarrassing anatomical poverty, as though time allowed researchers to read a hidden signature but refused to show the face of the person who wrote it. For Neanderthals, there are skulls, skeletons, burial contexts, injuries, tools, hearths, and long arguments built around bones that can be measured and compared. For Denisovans, the record begins with fragments so small that they force a different kind of humility. A finger bone, a few teeth, a jaw from a high plateau, genetic traces in sediment, possible fossils that may or may not belong to them. That is enough to prove existence, but not enough to restore a people whole. This scarcity gives the Denisovan story its particular tension. They were not rare in the sense of being unimportant. Their DNA suggests a population or group of related populations spread widely enough to leave genetic traces far beyond the Altai Mountains. Yet the physical remains that can be confidently connected to them are astonishingly few. It is not that Denisovans lived only as a handful of individuals huddled in one Siberian cave. It is that the conditions required to preserve ancient human bone, then allow it to be found, dated, identified, sampled, and genetically analyzed, are extremely demanding. Most bodies vanish completely. Soil acidity, heat, moisture, scavengers, erosion, burial conditions, later disturbance, and simple bad luck erase the majority of ancient lives. The deep past is not a museum waiting underground. It is a disaster zone of missing evidence. A lesser-known detail helps explain why the Denisovan record stayed hidden for so long. A fossil does not come labelled with its lineage. A large tooth found in Asia may be placed in one category for decades, then reconsidered when new methods appear. A jaw without DNA may look archaic, but archaic in Asia can mean many things. It might belong to a late Homo erectus-like population, a Neanderthal-related group, a Denisovan, an unknown lineage, or a population shaped by mixing. Before ancient DNA and protein analysis, many fragmentary fossils were difficult to place securely because there were no clear Denisovan reference skeletons. In a strange way, the Denisovans were both everywhere as a possibility and almost nowhere as a certainty. This is why teeth matter so much. Teeth are among the hardest parts of the body, and they survive where other bones fail. They preserve shape, wear, sometimes proteins, and occasionally DNA. Denisovan-associated teeth from Denisova Cave are unusually large compared with many modern human teeth, and their form has led researchers to wonder whether Denisovans may have carried a robust anatomy, unlike the more familiar Neanderthal pattern. But scholars still debate how much can be inferred from teeth alone. A tooth can suggest body size, diet, developmental pattern, and evolutionary relationship, but it cannot reliably give a face. It does not show skin, hair, posture, voice, expression, or the way a person moved through firelight at the cave mouth. It is a clue, not a portrait. The jaw from the Tibetan Plateau deepens the mystery. Found far from Denisova Cave, in a harsh, high-altitude landscape, it suggests that Denisovan-related people may have lived in environments that would challenge even well-equipped modern humans. The mandible is robust, with large teeth, and although it did not originally yield DNA in the familiar way, protein evidence helped connect it to Denisovans. That connection matters because it expands the image of Denisovans from cave shadows in Siberia to a wider Asian presence. It also shows how the future of human origins research may depend not only on DNA, which often degrades, but on older and tougher molecular evidence. Proteins can sometimes survive where genetic material does not, allowing scientists to test fossils once considered unreadable. Still, the picture remains incomplete. No Denisovan skull has yet been widely accepted as the defining face of the lineage. No complete Denisovan skeleton allows confident reconstruction of height, body proportions, or gait. No set of grave goods tells us what they believed. No preserved camp with an unmistakable Denisovan signature lets us speak easily about their daily routines. Even the tools found in Denisova Cave are not always simple to assign, because different human groups used the cave at different times. Archaeological layers can be complicated, materials move, occupations overlap, dating has margins of uncertainty. What survives in the record suggests presence, activity, and adaptation, but it does not offer a clean biography. And yet this absence should not be mistaken for emptiness. The genetic record gives Denisovans a kind of reality that bones alone cannot. Their genomes show relationships, separations, interbreeding, and inherited traits. They reveal that Denisovans shared a common ancestry with Neanderthals after both had split from the lineage leading to most modern humans. They show that Denisovans were not a single frozen moment in Siberia, but part of a larger and likely diverse population history. Some analyses suggest deep divisions among Denisovan-related groups, meaning that the Denisovans who contributed ancestry to people in Oceania may not have been identical to the Denisovan individual from the Altai. No single explanation fully accounts for the pattern, and researchers continue to refine it as more samples appear. There is something profound in this imbalance. The Denisovans are among the best-known ancient humans genetically and among the least known physically. Science can compare parts of their genome with living populations, trace inherited variants, and estimate ancient separations. But it cannot yet say with certainty what a Denisovan face looked like when turned towards snow, rain, smoke, or dawn. It cannot tell whether their hair was thick or fine, whether their build varied across regions, whether northern and southern Denisovan populations looked markedly different, or how they understood one another across distance. The evidence remains incomplete, and that incompleteness is not a weakness in the story. It is the story. For long-form history, there is a temptation to fill missing spaces with drama. The Denisovans invite that temptation more than most, because their absence feels almost designed for imagination. But the better mystery is not fantasy. It is the tension between how much can be known and how much has vanished. A people can survive in the genome and disappear from the eye. A lineage can shape living bodies while leaving almost no body of its own. A world can be crowded with humans and still become nearly silent. Denisovans force modern people to accept that the human past is not limited to what can be pictured easily. Sometimes the most important ancestor is not the one whose skull rests under glass, but the one whose existence had to be discovered from a few chemical letters preserved in darkness. So the forgotten age becomes stranger, not because it hides impossible civilizations, but because it hides real human populations in fragments. These people lived, adapted, met others, carried knowledge, raised the next generation with care, and vanished as a recognizable form before any city could write their name. The bones are few, but the signal is clear. Somewhere across ancient Asia, beyond the reach of most surviving evidence, Denisovans occupied landscapes now divided by modern borders and modern assumptions. Their scarcity in the ground does not make them small. It makes the surviving traces more powerful, because each one must carry the weight of thousands of lost lives. The more the fragments are studied, the less the old human family tree looks like a clean arrangement of separate branches. For a long time, it was tempting to place ancient humans in orderly succession, as if one type stepped aside and another took its place with the neatness of a museum display. Homo erectus, then archaic humans, then Neanderthals, then modern humans, each arranged like figures moving across a stage in one direction. Denisovans disturb that picture. They do not fit comfortably into a simple line, because they belong to a world where human groups split apart, endured separately for immense spans of time, and then sometimes met again closely enough for their descendants to carry mixed inheritance. The closest known relatives of Denisovans are Neanderthals. Both lineages appear to have shared a common ancestor after their wider branch had already separated from the ancestors of most modern humans. In broad terms, this means Denisovans and Neanderthals are sister groups, two related human populations that follow different histories across Eurasia. Neanderthals become especially associated with Western Eurasia, from Europe into parts of Western and Central Asia. Denisovans, from what the evidence now suggests, belong more strongly to Asia, though the full shape of their range remains uncertain. The split between them was not a quick historical event that anyone could have noticed. It was a deep evolutionary separation, stretching across hundreds of thousands of years as populations adapted to different landscapes, climates, and pressures. Yet separation did not mean isolation forever. The human world before civilization was not divided by walls or flags. It was divided by mountains, rivers, ice, deserts, forests, seasons, and distance. But these barriers changed. A cold period might open grassland corridors. A warmer period might shift forests and animals. Sea levels could expose land, then drown it again. Groups moved because food moved, weather moved, and survival required movement over long enough time. Lineages that had been separate could encounter one another again. This is one of the great lessons of ancient DNA human prehistory is not a story of pure sealed populations. It is a story of contact. Denisova Cave itself holds a remarkable expression of that contact. Among the discoveries connected to the site is the individual often described as having a Neanderthal mother and a Denisovan father, a first-generation hybrid. That fact alone changes the emotional scale of the story. It shows that Neanderthals and Denisovans were not just distant names in a genetic chart. They met as living populations, and in at least some cases, their children belonged to both worlds. The evidence remains incomplete, and it cannot tell us the circumstances of every contact. It cannot say whether such encounters were common in some regions or rare accidents preserved by chance. But the existence of such an individual proves that the boundaries between ancient human groups were porous. Modern humans, too, enter this tangled pattern. When Homo sapiens expanded beyond Africa, they did not walk into an empty continent. They entered landscapes already known by others. Some groups of modern humans met Neanderthals. Some met Denisovans or Denisovan-related populations. The proof is still present in living genomes. Many people outside Africa carry small amounts of Neanderthal ancestry. Some populations, especially in parts of Oceania and island Southeast Asia, carry higher levels of Denisovan ancestry than most others. Other Denisovan signals appear at lower levels in parts of Asia. These patterns suggest not one simple meeting, but multiple episodes, perhaps involving different Denisovan-related populations across different regions. This is where the word Denisovan becomes both useful and limited. It began with one cave and a few remains, but the genetic legacy suggests a wider family of related populations. The Denisovan individual from the Altai may not represent every Denisovan-related group across Asia. Some of the ancestry found in living people may come from populations that had been separated from the Altai Denisovans for a very long time. Scholars still debate how many distinct Denisovan lineages contributed to modern humans, where those contacts occurred, and how much of the story remains hidden in regions where ancient DNA rarely survives. Tropical climates, for example, are often harsh on DNA, which means some of the places most important to Denisovan human contact may be among the hardest to read genetically. What emerges is not a battlefield myth of one species replacing another in a single dramatic sweep. Competition surely existed at times, as it does among any groups needing land, water, shelter, and food. But no single explanation fully accounts for the genetic record. There was also interbreeding, coexistence, absorption, and perhaps long periods of passing awareness at the edges of one another's worlds. A group might know a neighbouring valley was used by others without needing a formal name for them. Strangers might be avoided, watched, joined, or exchanged with, depending on circumstance. We cannot recover the social meanings behind most of these encounters, but the biological evidence proves that the encounters happened. This makes identity in the deep past more difficult and more human. A person living 60,000 or 50,000 years ago might carry ancestry from more than one ancient lineage. Their body might hold adaptation shaped in one population and passed into another. Their children might inherit a mixture that later becomes part of a much larger human story. The categories used by science are necessary, but the lives themselves were not categories. Neanderthal, Denisovan, Homo sapiens. These are names applied from far away, after the fact, to patterns in bones and genomes. The people themselves moved through hunger, weather, memory, affection, caution, and skill. They did not live as labels. Denisovans also remind us that extinction can be misleading when genes remain. As a visible population, they disappear. As a contribution to later humans, they do not vanish completely. Some inherited Denisovan variants may have helped later human groups adapt to particular environments. The most famous example involves high-altitude adaptation in Tibetan populations, where a gene variant associated with efficient response to low oxygen appears to have Denisovan origins. That does not mean Denisovans were simply a toolkit waiting for modern humans. It means that ancient contacts had consequences. In the deep past, a meeting between populations could echo through thousands of generations. There is a quiet gravity in this tangled family. The forgotten age was not populated by one humanity, but by several humanities, close enough to share ancestry, different enough to follow distinct histories, and connected enough to leave traces in one another. The old question of who we are becomes harder to answer cleanly. Modern humans are not separate from all vanished human forms in the way earlier generations imagined. Our story is partly made of encounters with them, somewhere in the inheritance of living people. Denisovans remain not as ghosts in a legend, but as biological memory. Their bones are few, their faces uncertain, their tools difficult to assign. Yet the family connection is written into the body of humanity itself. Once Denisovans are understood as part of the tangled human family, the cave in Siberia begins to feel too small for them. It remains the place that gave them a name, the place where their genetic presence first stepped out of darkness, but it cannot be mistaken for the boundary of their world. A single cave can preserve a lineage. It cannot contain the whole history of that lineage. The DNA points outward, away from the Altai Mountains, across the enormous width of Asia, toward landscapes so varied that the word Denisovan begins to seem less like the label for one isolated group, and more like a doorway into a whole forgotten human geography. Asia in the late Pleistocene is not one environment. It is a continent of extremes and corridors. In the north, cold steppe stretches beneath hard skies, with herds moving across open ground and predators following the lines of hunger. In the center, mountains divide and connect, forcing movement through passes, valleys, and river systems. Farther south and east, monsoon forests, coastlines, caves, island chains. and warmer lowlands create worlds that preserve evidence poorly but may have mattered enormously. Between them lie deserts that expand and contract, lakes that appear and vanish, and grasslands that shift with climate. For ancient humans, this is not a map. It is a living puzzle of risks, shelters, roots, and seasonal knowledge. The first Denisovan genome came from the Altai, but modern human genomes suggest Denisovan-related ancestry in places far from Siberia. Some present-day populations in Oceania and island Southeast Asia carry notable Denisovan ancestry. Other traces appear in parts of East Asia and Southeast Asia, though often in smaller amounts and with complicated patterns. This does not mean Denisovans marched across Asia as one uniform people in a simple migration. The evidence suggests something more difficult and more interesting. Denisovan-related populations may have been widespread, diverse, and separated from one another for long periods, perhaps adapting to very different local worlds before some of them encountered ancestors of living humans. That possibility changes the scale of the mystery. If Denisovan ancestry is strongest today in regions far to the southeast of Denisova Cave, then some important contacts between Denisovan-related groups and Homo sapiens may have happened far from the cave that revealed them. The cave becomes a preserved northern window into a broader population history. It is possible that the Denisovans of the Altai were only one branch of a wider archaic Asian humanity. Scholars still debate the exact roots, timings, and number of interbreeding events, but the pattern is hard to ignore. The name comes from Siberia. The legacy points much farther. This is one of the strangest features of the story. The best physical evidence comes from cold or relatively favourable environments where ancient molecules can survive, while some of the most important genetic traces in living people point toward warmer regions where ancient DNA is often destroyed. Heat and humidity are enemies of genetic preservation. Tropical soils can erase bones quickly. Caves may collapse, coastlines may drown, and human camps made of wood, leaves, fibre, and hide can disappear almost completely. So the places where Denisovan-related people may have met modern humans most significantly may also be the places where their remains are hardest to find. The archive is not evenly distributed. It favours cold, dry, protected places, and this creates a distorted view. Imagine, then, the Denisovan world not as a single territory with borders, but as scattered populations across old Asia. Some may have lived in mountain zones, using caves and valleys as recurring shelters. Some may have followed herds across open steppe. Others may have occupied forest edges, river systems, or warmer southern landscapes where almost nothing of them has survived. They may not all have looked exactly alike. They may not all have carried the same adaptations. Their tools may have varied according to local stone, local prey, and inherited tradition. The evidence remains incomplete, but what survives in the record suggests that ancient Asia held more human diversity than the bones alone once revealed. This matters because old ideas about human expansion often treated Asia as an empty stage waiting for modern humans to cross it. The Denisovan signal proves otherwise. When Homo sapiens moved through Asia, they entered worlds already inhabited by other humans with deep local histories. These were not passive background figures. They had endured climates, learned landscapes, and maintained populations long enough to leave genetic traces in newcomers. In some places, contact may have been brief. In others, it may have unfolded over generations. There may have been regions where modern humans encountered Denisovan-related people more than once, or encountered different archaic groups at different times, each with its own history. The landscapes themselves would have shaped those encounters. A river valley can draw different groups toward the same resources. A mountain pass can funnel movement through a narrow route. A coastline exposed by lower sea levels can open a road that later disappears beneath water. During glacial periods, sea levels fall dramatically, exposing land bridges and broad coastal plains now lost offshore. This is a crucial but easily forgotten detail. Much of the Pleistocene world where people walked is no longer land. Camps, paths, shell-gathering places, and meeting zones may lie underwater, erased from ordinary archaeology. The silence of the record is not always absence. Sometimes it is drowning. Denisovan range expansion also raises questions about population size. Were they numerous across Asia, or were they thinly spread in small groups connected by rare movements? Ancient DNA cannot yet answer this fully. Genetic diversity hints at structure, separation, and deep history, but it does not provide a census. Small populations can persist for long periods if they know their environment well, yet they can also be vulnerable to climate shocks, disease, resource shifts, and absorption by larger incoming groups. No single explanation fully accounts for the Denisovan pattern. Their traces are strong enough to prove significance, but too scattered to reveal the full shape of their world. Still, the outline of that world is becoming larger, from the Altai to possible links in East Asia, from signals in modern genomes to fossils being re-examined across the continent. The Denisovans are slowly changing from a cave discovery into a continental mystery. Each new clue widens the darkness rather than closing it. Instead of one unknown human in one Siberian chamber, researchers now face the possibility of a broad archaic Asian population history, with branches that may have survived in different regions, met modern humans at different times, and contributed different fragments to living people. And so the forgotten age grows crowded again, before cities, before states, before fields of grain tied people to one place. Asia may have held multiple human worlds overlapping across time. Some left skulls, some left tools, some left only teeth, some left DNA inside people who would never know their names. The Denisovans stand at the center of this hidden geography, not because they explain everything, but because they reveal how much had been missed. A small bone in a cold cave opened a door, and beyond that door was not one lost tribe, but a continent of possibilities, stretching through mountains, rivers, drowned coasts, and vanished paths no map can fully restore. Across that widened map, the hardest question is also the most human one. What did they look like when they stood in the light? A genome can reveal kinship, interbreeding, population history, and inherited adaptations, but it does not easily give back a face. The Denisovans remain close enough to touch through DNA, and distant enough to evade the eye. They are not like the pharaohs whose profiles survive in paint and stone, not like Roman emperors with names attached to marble, not even like Neanderthals, whose heavy brows and broad bodies can be reconstructed from a richer fossil record. Denisovans are still figures at the edge of the fire, partly visible, partly hidden, known by fragments that seem too small for the burden placed upon them. The first temptation is to imagine them from their relatives. If Denisovans are sister to Neanderthals, perhaps they looked somewhat Neanderthal-like, strong bodies, archaic faces, heavy jaws, thick bones shaped by cold and difficult landscapes. But that is only a starting guess, not a reliable portrait. Sister lineages can diverge in important ways. Populations spread across different environments can vary. A Denisovan group in the Altai Mountains may not have looked exactly like a Denisovan-related group farther south or east. The evidence remains incomplete, and the word Denisovan may cover more diversity than a single face could ever show. The few fossils connected to them give hints, and those hints lean toward robustness. Some Denisovan-associated teeth are strikingly large, with features that do not fit neatly into the expected modern human or Neanderthal pattern. Teeth may seem humble, but in paleoanthropology they are stubborn witnesses. They survive when skulls collapse, when limbs crumble, when ordinary bone is eaten by soil and time. A molar can preserve shape, wear, growth, and sometimes molecular evidence. It can suggest relationships and habits, but a tooth is also frustrating. It tells scientists that a person once chewed, aged, grew, and belonged to a lineage. It does not show the eyes, the nose, the skin, the expression, or the way the face changed with sleep, weather, hunger, attention, or calm. The jaw from the Tibetan Plateau adds another piece to this uncertain image. It is robust, with large teeth, and its connection to Denisovans through protein evidence opened a new window onto their possible anatomy. This mandible does not give a full skull, but it does suggest that at least some Denisovan-related people were powerfully built in the lower face. A strong jaw does not mean crude behavior, and this point matters. For many years, popular images of ancient humans confused robust anatomy with lower intelligence, as if a heavy bone meant a simple mind. That idea belongs more to old prejudice than to science. Body form reflects ancestry, development, diet, climate, and mechanical stress. It does not rank human worth. The Denisovans may have looked unfamiliar to modern eyes, but unfamiliar does not mean primitive in the careless sense. There is another lesser-known complication. Some fossils from East Asia that were found long before the Denisovan genome was sequenced have become newly interesting. Certain archaic human remains from China and nearby regions show combinations of features that do not fit comfortably into classic categories. They are not easily called Neanderthal. They are not simply modern human. Some may represent Denisovan-related populations, mixed populations, late surviving archaic humans, or lineages still not fully understood. Scholars still debate these assignments, and caution is necessary because resemblance alone can mislead. Without DNA or proteins, a fossil can sit in an uncertain space for decades. Yet the Denisovan discovery changed how scientists look at those old bones. It raised the possibility that a face once considered unplaceable might belong to a population whose name had not yet been invented. Trying to reconstruct Denisovan appearance from DNA has also produced intriguing but debated work. Genetic information can sometimes suggest aspects of skeletal development by comparing patterns of gene regulation and inherited variants. From such approaches, researchers have proposed possible Denisovan traits, perhaps including a broad skull, strong jaws, and other archaic features. But this is not the same as looking at a complete skull. It is an inference built from difficult data, and no single reconstruction should be treated as a final image. The past has a way of punishing overconfidence. One new fossil can overturn a graceful model, one better preserved jaw, one skull fragment, one ancient genome from a warmer region could change the picture sharply. Still, even uncertain details help pull Denisovans away from abstraction. These were bodies moving through real weather. If some were robust, that robustness had meaning in the world of survival. Strong jaws and large teeth may reflect inherited anatomy, diet, or developmental patterns shaped over deep time. Bodies adapted not to a concept of progress, but to local pressures, cold, altitude, seasonal scarcity, long movement, tough food. and the demands of repeated labour leave their influence across generations. The Denisovans were not designed for display in a modern imagination. They were shaped by the old practical demands of staying alive. It is worth pausing on how much can not yet be known. Their height is uncertain, their average build is uncertain, their regional variation is uncertain, their skin tones, hair textures, facial range, and voices are beyond confident reconstruction from the current record. Even the way they clothed or decorated themselves is largely unknown. In colder places, some form of protective covering would have been necessary for survival, especially in high latitudes and mountain climates. But the materials would usually vanish. Hide, fur, plant fibre, sinew, cord, and wood rarely last across such time. What survives in the record suggests adaptation, but not wardrobe. It suggests bodies, but not presence in the full human sense. And yet the absence of a face may be part of why the Denisovans feel so powerful. They resist being turned into a single museum image. They remain multiple, unfinished, spread across regions and evidence types. A tooth from one place, a jaw from another, a genome from a cave, a trace in living people, a possible fossil under renewed debate. Each offers a different angle, none complete. The picture is like looking through frost on stone. Shapes are there. A human outline forms. Then it breaks again into uncertainty. The forgotten age before civilization is full of such broken outlines. It contains people who knew landscapes better than we know their bones, who carried lineages older than any kingdom, who may have met other humans beside rivers and mountain paths without leaving a scene clear enough for archaeology to recover. The Denisovan face is still missing, but perhaps that missing face teaches something important. Human history did not begin when people became easy to recognize. It did not begin when faces were carved, named, painted, and buried under monuments. It was already unfolding when a person with large teeth and a strong jaw moved through the thin light of an Ice Age morning, leaving behind almost nothing except the faint possibility that, one day, a fragment would be enough. To imagine Denisovan life between ice and forest, it is necessary to begin with the landscape rather than the people, because the landscape decides so much. It decides where animals gather, where water freezes, where stone can be found, where shelter matters, where hunger sharpens, and where movement becomes dangerous. The world before civilization is not a stage built for humans. It is a shifting force that humans must read constantly. A valley that feeds one generation may grow cold or dry for another. A forest that shelters animals may retreat. A river may cut a new course. A cave that offers protection may also attract predators, and a plain that opens a route may expose travellers to weather without mercy. In the Altai region, where the Denisovan name begins, the late Pleistocene world changes again and again. Cold steppe, patches of woodland, river valleys, and mountain environments create a mixed habitat rather than a single frozen wasteland. During colder periods, open landscapes expand and herds move through them. During milder intervals, forests and shrubs return more strongly. Humans living in such a place cannot be specialists in only one narrow sense. They need flexibility. They must know how to use stone, fire, animal movement, shelter, and memory together. They survive not through one invention, but through 1,000 ordinary decisions repeated well. A Denisovan group moving through such a world would live close to season. The year is not divided by calendar names, but by signs the return of certain animals, the thawing of water, the ripening of plants, the movement of birds, the thickness of hides, the angle of cold, the condition of snow. A safe place is never permanently safe. A good hunting ground is not always good. Food is not an abstract resource, but a pattern in time. To miss the pattern is to suffer. To remember it is to live. What survives in the record suggests that archaic humans used caves and open-air sites in relation to these changing opportunities. But the exact rhythm of Denisovan movement remains debated because their material signature is hard to isolate. Fire would have been central wherever cold pressed hard. Though the archaeology of fire can be complicated, hearths, burned bone, charcoal, ash lenses, and heated stone can show repeated use. But assigning a particular hearth to Denisovans rather than Neanderthals or modern humans at a shared site is not always simple. Still, in a cold landscape, fire is more than warmth. It changes food. It extends the usable day. It deters some animals. It makes a cave mouth into a human place. A circle of light against the old dark. It allows tools to be repaired, hides to be worked, bodies to rest, and stories or remembered knowledge to pass quietly between generations. No words survive from Denisovan mouths. But survival across such climates implies communication rich enough to coordinate work and learning. Food would have varied by region. In northern and mountain environments, large animals may have mattered greatly: deer, wild horses, bison, ibex, and other cold-adapted or seasonally available prey. Smaller animals, birds, fish, eggs, roots, berries, nuts, and other plant foods may also have contributed where available. The exact Denisovan diet remains uncertain because direct evidence is sparse, but no successful human group lives by one food alone if the environment offers alternatives. Even in popular images of the Ice Age, people are often reduced to hunters of large beasts. That picture is incomplete. Gathering, trapping, scavenging in some contexts, fishing, processing plants, storing knowledge of edible landscapes, and making use of seasonal abundance all belong to survival. Much of that activity leaves faint traces, especially when tools are made of wood or fibre. Stone tools provide some of the clearest surviving evidence of activity, but even here the story resists simplicity. Stone tools from Denisova Cave and surrounding regions show technological traditions across long periods. Yet assigning every tool to a species is difficult when multiple humans occupied the same site at different times. A blade or scraper does not carry the maker's DNA. Archaeologists must rely on dating, layers, associated remains, and patterns of manufacture. Scholars still debate which tool industries can be confidently linked to Denisovans, and which reflect Neanderthal or modern human activity. This uncertainty should not make the tools less meaningful. It makes them reminders that different human groups may have used similar solutions when facing similar problems. Daily life would have involved constant maintenance. Tools dull and break. Edges need retouching. Hides need cleaning, scraping, softening, drying, and shaping. Firewood must be gathered. Meat must be cut and shared. Bones may be cracked for marrow. Water must be found. Shelters must be chosen with care. Bodies need warmth. Feet need protection in harsh terrain. Children, when present in a group, would be protected and taught through ordinary participation rather than left outside the circle of care. Elders or injured adults, if they survived with group support, would carry memory of routes, seasons, and dangers. None of this is dramatic in the way a battle or a collapse is dramatic, but it is the deep drama of human endurance. One lesser-known point is that boredom, in the modern sense, may not map easily onto such lives. People sometimes imagine ancient foragers as spending every waking hour in desperate labour, or else as living in endless leisure. Neither extreme is reliable. Ethnographic comparisons must be used cautiously, because modern forager societies are not fossils of the past, but they do show that survival without agriculture can involve complex scheduling, social knowledge, rest, craft, play, ritual, and long periods of careful observation. Denisovans were not modern hunter-gatherers, and the evidence cannot tell us the texture of their day in detail. Yet it is unlikely that their lives were simply a frantic chase after calories. Survival depends on skill, and skill often looks quiet from the outside. The cave itself may have functioned as one node in a wider pattern. A group may return to a shelter because the place is known, because stone can be found nearby, because animals pass through the valley, because the entrance offers visibility, because older members remember it from earlier seasons. In such a world, memory is infrastructure. Without roads, memory is the road. Without writing, memory is the archive. Without permanent buildings, repeated places become landmarks of the mind. A cave is not a home in the later settled sense, but it may be part of a living map passed through bodies and attention. There is also the presence of danger, though it need not be described with spectacle. Large predators use caves too. Weather can trap. Injury can become serious. Scarcity can narrow choices, but danger is not the whole story. If the only lens is threat, ancient people become victims of their environment rather than skilled inhabitants of it. Denisovans survived for a very long time, and that means they succeeded across countless ordinary days. They read tracks, chose shelters, carried tools, warmed themselves, found food, maintained social bonds, and raised young with protective care. They were not waiting for the invention of civilization to become fully human. They were already living within one of humanity's oldest forms of intelligence, the ability to belong to a difficult landscape without controlling it completely. In the evening, the cold returns quickly. Smoke gathers near stone. Outside, the valley darkens. Somewhere beyond the cave mouth, animals move through brush or snow, and the old mountains hold the last light. Nothing in this scene will become a written record. No one will carve the group's name into a monument. The fire will die, the tools will scatter, the bones will break, and the floor of the cave will gather new layers above them. Yet for one night, in the forgotten age before civilization, the Denisovans are not fragments, not data, not a mystery. They are people in a hard world, doing what humans have done for longer than history can remember, keeping one another alive until morning. The longer one stays with the Denisovans, the more their survival begins to look less like a mystery of brute endurance and more like a mystery of skill. It is easy to imagine the deep past as a place where people simply reacted to hunger, cold, and fear. But that view makes ancient life too small. To survive for generations in Ice Age Asia required knowledge that was patient, precise, and often invisible to archaeology. It required knowing not only how to strike stone, but when to move, where to wait, what to carry, what to leave behind, which risks were worth taking, and how to pass all of this onward without writing a single word. The surviving record gives only the hardest edges of that knowledge. Stone flakes remain because stone is stubborn. Teeth remain because enamel resists decay. Burned traces remain when fire alters the chemistry of earth. But the greater part of daily skill would have lived in perishable things. A wooden spear shaft, a digging stick, a woven cord, a hide wrapping, a carrying sling, a repaired covering, a basket, a mat of plant fibers, a simple container made from bark or skin. These could have shaped daily survival as much as any stone blade, yet they are usually gone. the evidence remains incomplete because the past has a bias toward what is durable. It can make a highly skilled world look poorer than it was. Denisovan technology is especially difficult to isolate because the cave that preserved them also preserved the presence of others. Neanderthals use the same broad region. Modern humans later entered these landscapes. Archaeological layers can contain tools from different occupations across long spans of time, and a stone tool rarely identifies its maker on its own. Still, what survives in and around Denisova Cave suggests repeated human activity, tool-making, animal processing, and occupation across changing environments. This was not random sheltering by creatures barely aware of their surroundings. It was the use of a known place within a broader pattern of survival. A skilled toolmaker begins long before the first strike. They must know the stone. Some rocks shatter uselessly. Some fracture in ways that produce sharp, predictable edges. The right material may not lie beside the camp. It may require a journey to an outcrop, a riverbed, a slope where older stone has weathered loose. Choosing stone means remembering geology without having a word for geology. It means seeing possibility inside a dull lump and understanding how force will travel through it. A good strike is controlled, not wild. The angle matters, the weight matters, the sequence matters. A mistake can ruin the core. A success can produce an edge that cuts hide, meat, sinew, wood, or plant fibre with quiet efficiency. This kind of knowledge is cultural, even when the culture itself leaves few symbols behind. Culture does not require cities, it does not require writing. It begins whenever learned behaviour passes between individuals and persists beyond one lifetime. A child in such a group would learn by watching, staying close, being guided, and gradually taking part in safe tasks within the protection of adults. A younger member might first learn which stones are worth picking up, which plants are not to touch, how smoke behaves in a shelter, how to keep near the group in difficult weather, how to notice tracks without disturbing them. No dramatic scene is needed. The transfer of knowledge is quiet. It happens in repetition, correction, patience, and attention. There may also have been skill in sound and gesture that archaeology cannot recover. Denisovans were close relatives of humans whose survival depended on cooperation. It is reasonable to infer they had complex communication, though the exact form is unknown. They would have needed to coordinate movement, warn of danger, share information about food, teach techniques, and maintain social bonds. Whether their language resembled modern human language in structure is still debated, and no single piece of evidence can settle it. But a silent Denisovan world is almost certainly a false image. The landscape was not quiet to them. It was filled with signals, animal calls, wind shifts, cracking ice, footsteps, breath, gesture, memory, and the human sounds of a group staying together. The question of symbolic life is more difficult. Some artifacts from Denisova Cave, including ornaments and worked materials from later layers, have attracted attention, but assigning them confidently to Denisovans rather than modern humans is complicated. Popular accounts sometimes rush toward the most exciting conclusion, imagining Denisovan jewelry, art, ritual, and elaborate belief. Caution is necessary. The evidence must be dated, placed in context, and connected to the right population. Scholars still debate which objects belong to which human groups, yet caution should not become a denial of possibility. The absence of certainty is not proof that Denisovans lacked imagination. It only means that imagination is one of the hardest things for the ground to preserve. Even practical objects can carry meanings beyond utility. A tool may be made in a learned style because that is how one's group makes tools. A route may be followed because older people remember it. A cave may be returned to not only because it is useful, but because it is known. A particular stone source may matter because it links places across distance. A method of preparing hide or repairing an edge may be part of identity as much as survival. The deep past rarely separates practical life from social life as neatly as modern categories do. For people living close to season and landscape, doing something the right way can mean doing it the remembered way. This is where the idea of a forgotten age before civilization becomes misleading if handled carelessly. Civilization is often measured by monuments, writing, agriculture, government, and dense settlement. By that definition, Denisovans were not civilized, but civilization is not the same as intelligence, and absence of civilization is not absence of complexity. Small mobile groups can possess intricate ecological knowledge. They can track relationships, obligations, places, materials, and seasons across wide territories. They can remember events that matter. They can adapt techniques to changing climates. Their sophistication is not vertical. Like a tower, it is distributed across people, paths, tools, and memory. No single explanation fully accounts for how Denisovans survived across such varied environments, because the environments themselves were not one thing. A group in the Altai needed one set of habits. A group on a high plateau needed another. A group in warmer southern Asia, if Denisovan-related people lived there, would have depended on different plants, animals, shelters, and seasonal cycles. Yet beneath those differences lay the same basic human requirement. Knowledge had to outlive the individual. The landscape could not be learned from scratch by every generation. It had to be inherited. The quiet skill of survival is therefore one of the Denisovans' greatest legacies, even if it is also one of the least visible. They did not build cities that later travellers could stare at in ruin. They did not leave tablets explaining their laws. They did not carve their own names into stone, but they carried a way of being human through climates that broke many other possibilities. Their world was handmade in small acts, an edge struck cleanly, a fire protected from wind, a route remembered after snow, a hide prepared before cold, a warning given at the right moment, a child kept close within the safety of the group, a shelter chosen because someone knew what the weather would do. And when the night settled again over cave and forest, that skill did not announce itself, it did not glitter, it did not ask to become history. It simply allowed another morning to arrive, for thousands upon thousands of years, before any civilization could measure time in kings and dynasties. This was enough. The Denisovans survived by knowing their world deeply, and although most of that knowledge has vanished, the fragments left behind suggest a people who were not primitive shadows, but ancient specialists in the oldest human art remaining alive in a world that never promised permanence. Movement across the Denisovan world would not have felt like migration in the modern sense. With a line drawn across a map and an arrow showing progress from one region to another, it would have been slower, more uneven, more local, and more uncertain. A group does not wake one morning and decide to cross a continent. It follows food, avoids danger, remembers old paths, tests new ones, returns when possible, and sometimes keeps going because the world behind it has changed. Over thousands of years, such decisions can become a vast movement, but on the ground they're made in steps across a ridge, down a river valley, along the edge of a plain, toward a shelter that someone once knew, away from cold that has stayed too long. The late Pleistocene is full of such openings and closures. Climate shifts alter the shape of possibility. During colder periods, sea levels fall as ice locks up water, exposing coastlines, shelves, and land connections that are now submerged. During warmer periods, seas rise again, forests spread in some places, deserts change, and animal ranges move. For people without agriculture, mobility is not failure, it is intelligence. To move is to stay connected to a living landscape. To refuse movement when the world changes can be dangerous. The Denisovans, if their genetic traces truly reflect a wide Asian presence, must have been part of this old geography of movement, though the evidence remains incomplete and the details are still debated. Asia offers many possible roads, none simple. The Altai Mountains sit near a meeting zone of steppe, forest, river valleys, and high country. From there, one can imagine routes westward toward lands more associated with Neanderthals, eastward into the vast interior, southward through mountain corridors, or along river systems that create natural passages through difficult terrain. But imagination must be held carefully. Archaeology does not yet show a continuous Denisovan trail from Siberia to Southeast Asia or Oceania. What it shows is a northern fossil and genetic anchor, a high-altitude jaw in Tibet, ancient DNA and sedimentary traces in particular places, and modern human genomes carrying Denisovan inheritance far to the south and east. Between those points lies one of the great blank spaces in human origins. That blank space may not stay blank forever. New methods are changing what counts as evidence. A cave sediment sample can sometimes reveal who used a place even when no visible human bone survives. A tooth can be re-examined with better comparative data. Ancient proteins may identify a fossil where DNA has failed. Modern genomes can be modelled to infer episodes of contact with archaic humans in regions where fossils are missing. Each method has limits, and no single explanation fully accounts for all the patterns. But together they suggest that Denisovan-related populations were not confined to one mountain cave. Their movements, or the movements of populations related to them, shaped parts of Asia in ways only now becoming visible. The roads through this world were not built roads. They were corridors of habit. Rivers are among the oldest guides. A river offers water, animals, plants, stone carried from upstream, and a navigable line through uneven country. Valleys can protect from the worst wind or, in some seasons, trap cold air and danger. Mountain passes can be impossible in one climate phase and usable in another. Open steppe can allow long-distance visibility and herd following, but it can also expose travellers to storms and scarcity. Forests can offer shelter and food, but slow movement and hide predators. Every route has a price. Ancient humans learned these prices through bodies, losses, memory, and repeated return. Denisovans may have expanded not as a single wave, but as scattered populations occupying favourable zones over very long time. One group might settle into a mountain valley for generations, using nearby shelters and seasonal resources. Another might move along open grassland following herd animals. Another, far to the south, may have lived in environments that left almost no recoverable DNA. Over time, populations could become separated by distance and ecology. Their genes would drift. Their bodies might adapt. Their tool habits could diverge. Later, when climate shifted again, some populations might reconnect or meet other humans. The word Denisovan may therefore cover a deep structure of related groups rather than one unified people. This helps explain why Denisovan ancestry in modern humans is so complex. The ancestry found in some present-day populations does not look as though it all came from the exact same ancient group represented by the Altai genome. Some signals suggest contact with Denisovan lineages that had been separated from one another for long periods. Scholars still debate the number and location of these contacts, but the implication is powerful. Modern humans may have met not one Denisovan population, but several Denisovan-related groups, each carrying its own history. The Forgotten Age was not a single encounter at the edge of a cave. It may have been a series of meetings across a continent, most of them now invisible. Coasts add another hidden dimension. During glacial low sea levels, huge stretches of land now underwater were exposed. In Southeast Asia, the shape of islands and mainland connections differed greatly from today. Ancient shorelines, river mouths, mangrove edges, and coastal plains may have offered rich resources and movement routes. If Denisovan-related populations or modern humans carrying Denisovan ancestry moved through these zones, many of the most important places may now lie beneath the sea. This is a lesser-known but essential problem in deep prehistory. The map we excavate is not the map people lived on. Some of the easiest ancient routes are now drowned, and some of the camps most likely to preserve the story are beyond ordinary reach. Movement also does not mean constant wandering. Many mobile foragers move within known territories, returning to places when the season is right. They may have a wide home range without being aimless. For Denisovans, as for other ancient humans, a landscape could be remembered across years and generations. A cliff face, a cave entrance, a bend in a river, a stone source, a place where animals cross, a sheltered grove, a dangerous slope after thaw. These could form a mental map more useful than any drawn one. There is no need for permanent buildings when the land itself is known deeply enough to organize life. And yet movement brings contact. A group following a valley may encounter traces of others: a used hearth, broken stone, butchered bone, footprints in soft ground, smoke in the distance. The others may be Denisovan, Neanderthal, modern human, or another archaic population whose name is still missing. The evidence cannot usually tell us what happened in such moments. Avoidance is possible, exchange is possible. Conflict between adults is possible in some circumstances, though it should not be turned into the whole story. Interbreeding is known to have occurred between some human groups. Coexistence may have lasted in certain regions. The deep past likely contained many kinds of contact, most of them too subtle to leave a clear archaeological trace. The roads through a frozen continent were therefore not just physical routes. They were routes of genes, techniques, risks, and memories. A useful stoneworking habit could move with people. A genetic adaptation could pass from one population into another. A place known by one group could later become known by another. A lineage could vanish as a separate identity, yet continue inside descendants of those it met. This is how deep time works on human lives. It breaks the names and keeps the traces. Somewhere along these old roads, Denisovans crossed the immense distance between being a local cave discovery and becoming a continental presence. They did not leave signposts. They did not leave a migration epic. They left fragments in cold places, a jaw on a high plateau, signals in modern genomes, and the possibility that many of their paths are hidden under forest, sand, sediment, and sea. Their movement was not the march of civilization. It was older, quieter, and perhaps more astonishing. The slow occupation of difficult worlds by people who knew how to keep going when the land itself would not stay the same. The old roads do not only cross valleys and plains. Some climb into places where the body begins to argue with the sky. On the Tibetan Plateau, the air is thin, the cold can arrive without ceremony, and the land itself seems to resist easy human occupation. Even today, with roads, insulated clothing, stored food, and medical knowledge. High altitude asks a price from the lungs and blood. In the Pleistocene, that price would have been paid without maps, without metal, without written instructions, and without the long chain of tools modern people carry between themselves and the weather. Yet one of the most important Denisovan clues leads exactly there, to a world above ordinary breath. The Tibetan Plateau is sometimes called the roof of the world, but that phrase can make it sound still and majestic in a distant way. For ancient humans, it was not a postcard. It was a difficult living system of cold winds, strong sunlight, short growing seasons, broken terrain, dangerous storms, and animals adapted to heights where lowland bodies struggle. Oxygen is lower because air pressure is lower. A person not adapted to such conditions can tire quickly, sleep poorly, lose appetite, and face serious illness if they climb too high too fast. For long-term survival, the challenge is not only reaching the plateau, it is living there, returning there, finding food there, and raising generations there without the body failing under invisible pressure. This is why the Shiahi mandible matters so much. Found in a cave on the northeastern edge of the Tibetan Plateau, the jaw is not a complete Denisovan skeleton and does not give back a whole body, but its robust form and large teeth, combined with protein evidence, connect it to Denisovans or a Denisovan-related population. That connection changed the story because it placed Denisovan presence, or at least Denisovan-related presence, in a high-altitude region long before the plateau became part of any written human world. The evidence remains incomplete, and scientists continue to refine dates, contexts, and relationships. But the implication is extraordinary. A human cousin known first from a Siberian cave may also have been adapted to some of the harshest inhabited landscapes on Earth. Baishia Karst Cave, associated with the plateau evidence, adds another kind of atmosphere to the story. It is not merely a hole in the rock, it is part of a high, cold landscape, where shelter can become the difference between passing through and staying alive. Caves in such regions can protect from wind, preserve traces, and gather layers of activity across long periods. Sediments from cave floors may hold DNA even when bones are scarce. Stone tools and animal remains can show repeated human use of a place, though assigning every object to Denisovans must be done carefully. What survives in the record suggests persistence, not a single accidental visit. The plateau was not simply touched and abandoned. It may have been known. The most famous high-altitude legacy connected to Denisovans is genetic. Many Tibetans today carry a version of the EPAS1 gene region, associated with adaptation to low oxygen conditions, and research has linked this variant to Denisovan ancestry. The biology is subtle. At high altitude, the body must respond to lower oxygen, but producing too many red blood cells can create its own dangers. The inherited variant appears to help with more efficient adaptation, allowing people to live high without some of the harmful effects seen in less adapted populations. This does not mean modern Tibetans are Denisovans, nor does it mean one gene explains everything about high-altitude life. Human adaptation is always more complex than a single genetic switch. But it does mean that an encounter in the deep past may have helped later humans live where the air runs thin. There is a quiet power in that idea. A population that disappeared as a recognizable people may have passed along a biological tool suited to a landscape they knew, long after Denisovans themselves faded from view. One piece of their inheritance continued to matter in the bodies of modern humans. It is not a monument, but it may be more intimate than any monument. It works in blood and breath. It does not stand on a hill. It moves through generations. How did Denisovans come to tolerate such environments? No single explanation fully accounts for this, and the evidence is still developing. Perhaps some Denisovan-related populations lived at high altitude long enough for natural selection to favour traits that helped with low oxygen. Perhaps they moved seasonally between lower and higher zones, slowly building both cultural and biological adaptation. Perhaps the plateau was occupied in pulses, during warmer or more favourable periods, with caves serving as repeated shelters. The full pattern remains uncertain, but even occasional high-altitude occupation requires knowledge. People must know where animals graze, where water can be found, where storms gather, which routes remain passable, and how to protect the body from cold that steals strength quietly. The animals of such places would have shaped human life as well. Wild yaks, sheep, antelope, and other highland or mountain-adapted animals move through these landscapes according to seasonal patterns. Their presence offers food, hides, bone, sinew, and information about the land itself. Following them requires attention to terrain and weather. Plants, too, would have mattered when available. Though high-altitude environments limit abundance, fuel can be scarce. Fire becomes precious. A mistaken shelter choice can turn a night dangerous. The Denisovan skill here would not be a single dramatic invention, but a dense web of practical decisions: when to climb, when to descend, where to pause, what to carry, what to eat, how to stay warm, and how to read the body's warning signs. This is also where the Forgotten Age becomes surprisingly modern in its consequences. Ancient interbreeding is sometimes presented as a curiosity, a strange footnote to human origins. But high-altitude adaptation shows that it could shape survival in very real ways. A gene variant inherited from an archaic human population may have helped modern humans settle a demanding environment. Contact between human groups was not only a matter of ancestry percentages, it could become part of ecology. It could alter what landscapes later people could endure. In that sense, Denisovans did not vanish at the border of their disappearance. They continued as possibility inside other humans. Yet caution remains necessary. The Denisovan contribution to high-altitude adaptation is important, but it should not flatten the story of Tibetan survival into genetics alone. Culture matters, knowledge matters, clothing, shelter, fire, food practices, movement patterns, social care, and learned experience all matter. Bodies adapt through genes, but people survive through communities. What the EPAS-1 story offers is one thread in a much larger fabric, a sign that biology and culture, ancient contact and local knowledge, vanished populations and living people can all meet in the same breath. Standing on the imagined plateau, the Denisovan story changes shape again. It is no longer only a cave mystery, no longer only a fragment in Siberia, no longer only a shadow beside Neanderthals and Homo sapiens. It becomes the story of humans entering extreme worlds and leaving traces where even breathing is a challenge. Above the valleys and forests, where wind moves over rock and the sky feels close enough to press against the lungs, the Denisovans reveal one of their clearest legacies. They were not merely survivors of cold places. They may have been people of high places too, and in the thin air of the plateau, something of them still lingers every time an inherited breath does its quiet work. By the time Homo sapiens enters the wider Asian map in force, the land is already inhabited by other human stories. This is one of the most important corrections ancient DNA has given to the old imagination. Modern humans did not expand into a silent world, as if Eurasia were waiting empty beneath ice and stars. They moved through landscapes where Neanderthals had endured for hundreds of thousands of years, where Denisovan-related populations had learned mountains, valleys, plateaus, forests, and perhaps drowned coasts, and where other archaic groups may have left traces not yet securely named. The arrival of Homo sapiens was not the beginning of humanity outside Africa. It was the arrival of one human lineage into territories where other humans already knew how to live. The movement itself was not one neat wave. Groups of Homo sapiens had likely moved beyond Africa at different times, with some early expansions leaving little or no lasting ancestry in living populations, and later expansions spreading more widely. The evidence remains incomplete, especially because many early routes followed coastlines or warm regions where preservation is poor. But by roughly the later part of the Pleistocene, modern humans were moving across Western, Central, Southern, and Eastern Asia in ways that brought them into contact with older Eurasian populations. The maps drawn in textbooks show arrows. The real journeys were made of footsteps, pauses, failures, returns, births, deaths, and choices made at the scale of small groups. For Denisovans, the meeting with Homo sapiens is known most clearly not from a scene in the ground, but from inheritance. Somewhere, sometime, modern humans and Denisovan-related people had children together, and some of those children's descendants survived. The proof is carried in present-day genomes. This is a quieter kind of evidence than a battlefield layer or a dramatic cave painting, but it is harder to dismiss. Genes do not tell the whole story of contact, yet they show that contact became intimate enough to shape later populations. What survives in the record suggests not a single meeting, but several, and possibly with different Denisovan-related groups in different parts of Asia. The first encounters may have been cautious and practical. Imagine a modern human group entering a valley already used by others. They may notice broken stone, old fires, cut-marked bones, footprints, or the absence of animals where animals should be. Smoke in the distance might be enough to change a route. A cave that seems ideal may already belong to another rhythm of occupation. A river crossing may be known by more than one group. There is no need to imagine immediate conflict every time strangers appear. Avoidance is often the simplest solution in a large landscape. But avoidance cannot explain the genetic evidence by itself. At least in some places, contact went beyond watching from a distance. What did Homo sapiens bring into these meetings? They brought bodies shaped by African origins and long histories of adaptation, tool traditions that varied across regions, social networks, symbolic habits in some contexts, and a capacity for flexibility that will become increasingly visible in the archaeological record. But it would be wrong to imagine modern humans as walking into Asia with a complete and superior package while everyone else remained static. Neanderthals and Denisovans had their own long-tested knowledge. They knew local animals, seasons, stone sources, shelters, and risks. A newly arrived group may have had advantages in some situations and disadvantages in others. No single explanation fully accounts for why Homo sapiens eventually became the only surviving human lineage. This is where the story becomes more subtle than replacement. Competition likely mattered. Two human groups using similar resources in a difficult environment may pressure one another, even without constant violence. If one group grows faster, maintains wider exchange networks, adapts more flexibly to shifting climates, or recovers more easily from losses, it may gradually outlast another. But the genetic record also shows mixture. Some vanished populations were not simply pushed aside. They were partly absorbed. A Denisovan-related group might disappear as a separate identity while some of its descendants became part of expanding modern human populations. In such a case, disappearance and survival happen together. the Denisovan contribution to modern humans was not evenly spread. Some present-day populations in Oceania and nearby regions carry especially notable Denisovan ancestry, while other populations carry much less. This pattern suggests that important contact may have occurred in southern or southeastern parts of Asia, perhaps with Denisovan-related groups different from the Altai Denisovans. The exact geography remains debated. The routes into Sahul, the Ice Age landmass that included Australia and New Guinea, involved island crossings and coastal worlds that are now partly submerged. If Denisovan-related people lived somewhere along these routes, much of the archaeological evidence may be underwater, destroyed, or still undiscovered. The absence of a clean fossil trail does not erase the genetic signal, but it does make the story difficult to place on the ground. There is also a lesser-known twist. Denisovan ancestry in living humans does not appear to come from only one source population. Some studies suggest multiple Denisovan-related contributions, meaning that different groups of Homo sapiens may have encountered different Denisovan lineages at different times. This fits the larger pattern already hinted at by the fossils and genomes. Denisovans were likely not one uniform people. They may have been a broad set of related archaic populations, some separated by deep time and distance. When modern humans entered Asia, they may have entered not one Denisovan world, but several. The emotional difficulty is that genetics can reveal intimacy without revealing relationship. It can show interbreeding, but not how people understood one another. Were some contacts tense? Almost certainly, in some places and moments, because resources, territory, and uncertainty can create danger between adult groups. Were some contacts cooperative? Possibly. Did individuals move between groups, willingly or through circumstances we cannot reconstruct? Perhaps. Did shared children grow up within one community or between communities? The evidence cannot say. Scholars still debate the social meaning of archaic modern human mixture, and it would be irresponsible to pretend that DNA can recover the human texture of every meeting. It gives the outline, not the faces. Yet even the outline changes everything. It means the modern human story is not pure isolation. It is braided with the lives of people who are gone. The expansion of Homo sapiens across Asia was not simply a triumphal march. It was a process of entering older worlds, learning some landscapes from scratch, meeting other humans who had already survived there, and sometimes inheriting pieces of their biology. The old idea that history begins with us alone becomes harder to defend. We are not the only authors of our own deep past. As modern humans spread, the balance of the human world shifted. Denisovans remained in the record only as fragments and ancestry, while Homo sapiens became increasingly visible through tools, ornaments, movement, and eventually the long road towards settled life. But that later visibility should not blind us to what came before. The first meetings between sapiens and Denisovans happened in a world without written names, without borders, without witnesses who could leave an account. Somewhere in Asia, under skies that changed with glacial dust and monsoon rain, two kinds of humans came close enough that the boundary between them did not hold, and from that closeness, part of the vanished world crossed into the future. The disappearance of the Denisovans is not marked by a burned city, a collapsed palace, or a final battlefield that can be pointed to on a map. There is no last inscription, no royal tomb, no abandoned street where their ending can be staged for the eye. Their vanishing is quieter and more difficult. It happens in the same way they entered modern knowledge through fragments, absences, and traces that do not explain themselves. At some point, Denisovans cease to exist as a recognizable population, yet no layer of earth announces the moment. The record simply thins until their bodies are gone, while pieces of their ancestry continue elsewhere. This is what makes their disappearance so strange. In ordinary language, extinction sounds like a clean ending, but for human populations, the word can hide several different processes. A group can die out biologically, leaving no descendants. A group can be absorbed into another, losing its distinct identity while some of its genes continue. A group can fragment into smaller populations that eventually merge, shrink, or vanish separately. A name can disappear long before ancestry does. For Denisovans, the evidence points toward a complicated ending rather than a single event. No single explanation fully accounts for this disappearance, and the evidence remains incomplete in exactly the places where the answer may matter most. Climate is one obvious force. The late Pleistocene was unstable, and instability is dangerous for small populations. Glacial cycles reshaped habitats across Eurasia. Cold periods expanded steppe and ice-influenced environments. Warmer intervals changed forests, animal ranges, water sources, and routes. A population adapted to one pattern might struggle when the pattern shifted. If Denisovan-related groups were spread across Asia in separate pockets, each pocket may have faced different pressures. A northern mountain group might suffer from harsh cold, prey changes, or shrinking refuges. A high-altitude group might endure low oxygen and seasonal scarcity. A southern group, if it existed in warmer regions, might face monsoon shifts, sea level changes, or ecological competition. The Denisovan world was probably not destroyed all at once. It may have been worn down unevenly. Population size may have mattered just as much as climate. Small groups can be resilient when they possess deep local knowledge, but they are also vulnerable. A few bad seasons, reduced fertility, disease, accidents among adults, or the loss of key knowledge holders can have long-term consequences. In a small population, every relationship matters. Every skilled toolmaker, tracker, healer, route rememberer, or experienced elder carries knowledge that cannot be replaced easily. The archaeological record rarely preserves such social fragility. It shows stone and bone, not the moment when a group becomes too small to maintain itself across a difficult landscape. Scholars still debate the demographic history of Denisovans, but genetic evidence suggests structured populations rather than one vast stable mass. Fragmented groups may endure for a long time and then disappear quickly in local terms. The arrival and expansion of Homo sapiens added another pressure, but not necessarily in the simple form often imagined. Popular stories prefer a dramatic replacement, as if modern humans swept across Eurasia and drove every other human group into extinction by force. Reality is likely more complicated. Competition for resources may have occurred, especially in regions where different groups use similar animals, shelters, or stone sources. Modern humans may have had advantages in larger social networks, symbolic communication, flexible technologies, or the ability to maintain connections across wider distances. These advantages, if present, would not need to be overwhelming in every encounter. Over many generations, even small differences in population growth, exchange, and recovery from hardship can shift the balance. But the genetic evidence prevents the story from becoming only one of competition. Denisovans and modern humans interbred. That means some Denisovan groups did not simply vanish in isolation from the newcomers. They entered the ancestry of later people. In this sense, their disappearance may partly be an absorption. A Denisovan-related population could lose its separate identity as its descendants became part of expanding Homo sapiens groups. Over time, the visible culture, body form, and social continuity of one population might dissolve, while selected fragments of its genome persisted. This is a quieter ending than extinction by catastrophe, but it is no less profound. A people can disappear as a people and still remain inside the future. There may also have been Denisovan groups that never met modern humans in large numbers. Some may have vanished locally before contact. Others may have survived in regions where evidence has not yet been recovered. The last Denisovan is unknown. There is no final fossil that closes the story. This is a lesser known but important point. Science can identify some moments when Denisovans existed, but it cannot yet identify the moment they ceased to exist. Their ending may have varied across Asia. One population may have disappeared tens of thousands of years before another. Some Denisovan-related ancestry in modern people has been interpreted as coming from contacts later than the first major expansion of Homo sapiens into Eurasia, though the details remain debated. The disappearance was probably not a single date. The environment itself helped hide the answer. If Denisovan-related people lived in warm or humid regions, their bones and DNA would be less likely to survive. If they used coastal plains, some of their sites may now be underwater. If their camps were made from perishable materials, little would remain. If they were mobile and thinly spread, their archaeological footprint would be faint even while they lived. The silence after them may therefore reflect both real disappearance and poor preservation. Absence in the ground is not always absence in the past. It may be the result of chemistry, erosion, sea level rise, and the long unfairness of time. Disease is another possibility, though evidence is hard to pin down. Contact between human groups can bring new pathogens, and small populations may be vulnerable to illnesses carried by others. Yet it would be careless to build a full Denisovan extinction theory on disease alone, because direct proof is lacking. The same caution applies to theories of violent conflict, sudden disaster, or a single climatic collapse. Each may have played a role in some places, but the known evidence does not support one sweeping explanation. The disappearance of Denisovans likely came from a combination of pressures, environmental change, demographic fragility, competition, interbreeding, local extinctions, and the expansion of Homo sapiens into old Denisovan worlds. There is a melancholy patience in such an ending. It is not cinematic in the ordinary sense. It does not give us a last night in the cave that can be known, a final group on a ridge, a final fire under snow. Those scenes belong to imagination, not evidence. What can be said is more restrained and perhaps more haunting. The Denisovans survived for immense spans of time. They adapted to cold, mountains, and perhaps many other Asian environments. They met other humans. They contributed to living people. Then, as a distinct population, they faded beyond recognition. The world continued. Rivers shifted. Sediments covered cave floors. Modern humans carried on, not fully separate from those they had replaced, but partly made from contact with them. Their disappearance, therefore, is not a clean erasure. It is a transformation into fragments. A bone in Denisova Cave, a jaw on the Tibetan Plateau, a genetic variant helping breath in thin air, an ancestry signal in distant islands and coasts. The Denisovans vanish from sight, but not from consequence. Before civilization, before any human story could be written down, one human world ended by becoming hidden inside another, and for tens of thousands of years. No one knew that the hidden world had ever been there at all. The Denisovans disappear from the visible record, but they do not disappear from the human body. This is one of the strangest turns in the story, A people can leave almost no bones, no city, no carved name, no remembered language, and still remain present in the chemistry of living descendants. Their legacy does not stand above ground like a ruin. It travels quietly inside cells, broken into small inherited segments, copied from parent to child across thousands of generations. Most people carrying those traces will never feel them as a memory. They do not arrive as images or voices. They are older than family names, older than nations, older than any tradition that can point backward and say, "There they are." Yet modern genetics can find them, scattered like ash from a vanished fire. When researchers compare living genomes with ancient Denisovan DNA, they find that some present-day populations carry Denisovan ancestry. The strongest known levels occur among indigenous peoples of Oceania, including Papuan and some Aboriginal Australian populations. Though the exact histories are complex and must be handled with care, Denisovan ancestry also appears at lower levels in parts of East Asia, Southeast Asia, and among some other groups, but not in one simple pattern. This uneven distribution immediately tells us that the old meetings were not evenly spread across the world. They happened in particular places, involving particular ancient populations, and then their traces moved with the descendants of those who survived. That pattern also suggests that the Denisovan legacy in living people did not come from a single source. Some inherited segments seem closer to the Altai Denisovan genome, while others appear to come from Denisovan-related populations that have been separated from the Altai group for a very long time. Scholars still debate how many Denisovan lineages contributed to modern humans, where those contacts happened, and when. But the larger message is clear enough. The name Denisovan may cover a wide range of related archaic humans, and modern people may carry traces from more than one branch of that hidden family. The ancient world was not only populated by different species or lineages, it was populated by differences within those lineages, by regional histories inside the larger mystery. This is why the genetic legacy feels almost like a map drawn from the inside outward. Bones mark places where remains survived. Genomes mark ancient meetings whose locations may be lost. A person living today in New Guinea, Australia, island Southeast Asia, East Asia, or elsewhere may carry small Denisovan-derived segments that point back toward events not preserved in local archaeology. The contact itself may have happened on land now underwater, in forests where bones decay quickly, along coastal routes erased by rising seas, or in regions not yet excavated. The evidence remains incomplete, but the body can preserve history when the ground refuses. The amount of Denisovan ancestry is usually small in percentage terms, even where it is comparatively high, but percentage can be misleading. A small genetic inheritance can matter if particular variants affect survival, adaptation, or biology. The high-altitude example in Tibet is the clearest famous case, where a Denisovan-related variant helps explain adaptation to low oxygen. But Denisovan genetic influence may not be limited to altitude. Researchers have explored possible effects on immune response, metabolism, fat storage, blood traits, and other biological systems, though many proposed links remain under study. No single explanation fully accounts for the role of all Denisovan segments in living people. Some may have been useful, some may have been neutral, some may have been harmful and reduced by natural selection over time. The genome carries both history and filtering. Immune-related genes are especially interesting because contact between populations often brings contact between disease environments. A group adapted for a long time in one region may carry immune variants useful against local pathogens. When modern humans entered those regions and interbred with archaic populations, some inherited variants may have helped them respond to new biological challenges. This does not mean Denisovans were simply a storehouse of useful genes. They were people with their own histories, and natural selection afterward determined which fragments became more common, which faded, and which remained at low levels. Still, the possibility is powerful. A meeting tens of thousands of years ago may have shaped how some descendants responded to invisible threats. Other inherited fragments are harder to interpret. They sit in the genome like unread words from a damaged manuscript. Scientists can identify them as Denisovan in origin, compare their frequencies, and study nearby genes, but function is often difficult to prove. A segment may be associated with a trait without clearly causing it. A variant may matter in one environment and not another. A gene's effect may depend on many other genes around it. Popular accounts sometimes rush to claim that Denisovan DNA explains strength, cold tolerance, altitude, immunity, or mysterious abilities. Care is needed. The mainstream picture is more restrained and more interesting. Denisovan ancestry is real, unevenly distributed, sometimes biologically important, and still not fully understood. There is also a human tension in speaking about present-day populations. Genetic ancestry is not identity in the cultural sense. A person is not defined by an ancient percentage, and no living community should be reduced to being a container for archaic DNA. These inherited traces belong to deep population history, not to simple labels of worth, purity, or difference. In fact, Denisovan ancestry shows the opposite of purity. It shows mixture. It shows that human groups have been crossing boundaries for longer than civilization has existed. It shows that the bodies of living people are archives of movement, contact, survival, and disappearance. The Denisovan legacy therefore changes the way the forgotten age is remembered. It is not only behind us, parts of it are within us, not equally in every population, not always in visible traits, not as a simple story of inheritance, but as a real biological echo. The vanished people of Asia, known from a cave, a jaw, teeth, proteins, sediments, and genomes, are not locked in the past. They cross into the present wherever their inherited fragments continue. Some of those fragments may have helped humans live at altitude. Others may have influenced responses to disease. Many may simply persist as neutral traces of ancient contact, carrying no dramatic effect but still holding the fact of connection. This may be the most intimate form of archaeology. A stone tool lies outside the body, a bone rests in a drawer, a cave sediment sample belongs to a place, but inherited DNA makes the deep past personal without becoming sentimental. It means that the forgotten age before civilization did not end cleanly when farming began, or when cities rose, or when writing appeared. Older human worlds had already poured themselves into later humanity. The city builders, the farmers, the sailors, the herders, the kings, the nameless workers who raised monuments, all belong to a species already shaped by contact with vanished cousins. And so the Denisovans continue as ghosts inside modern genomes. Though ghost is only a metaphor, they are not supernatural, they are not legend, they are inheritance. They are proof that disappearance can be incomplete, that a people almost without bones can remain in blood and breath, and that the human story is not a clean line of replacement. It is a long mingling of lives, most of them unnamed, most of them lost, some of them still quietly present in the living world. The genetic legacy leads back to the method that revealed it, and here the Denisovan story becomes larger than Denisovans alone. Their discovery changed not only one branch of the human family, but the way the human past can be found. Before ancient DNA entered the center of the field, the deep story of humanity depended heavily on visible remains, skulls, jaws, teeth, tools, hearths, and the geological layers that held them. Those things still matter enormously. They are the body of archaeology and paleoanthropology. But the Denisovans proved that an entire human population could be hidden in the record until molecules gave it a name. A fragment too small to define by shape could overturn the map of human origins because it still held genetic memory. This was a profound change in authority. For generations, anatomy had carried the main burden of classification. Researchers compared bones, measured angles, traced similarities, debated whether a fossil belonged to one species or another. The arguments could be careful, brilliant, and necessary, but they were limited by what survived. If a skull was missing, a face was missing. If only a tooth remained, conclusions had to be cautious. If bones from warm regions decayed, whole populations could become nearly invisible. Denisovans exposed that weakness with unusual force. They were not first recognized because their skeleton looked different in a museum drawer. They were recognized because their DNA did not fit the expected pattern. From that moment, the human family tree became harder to draw and more honest. Ancient DNA showed that evolution was not a clean sequence of isolated forms. It showed mixture between Neanderthals and modern humans. It showed mixture between Denisovans and modern humans. It showed direct family-level contact between Neanderthals and Denisovans. It hinted at even older, more mysterious populations contributing to archaic genomes. The past became less like a ladder and more like a braided river, with channels separating, running apart for long stretches, and then joining again. No single explanation fully accounts for every genetic pattern, and scholars still debate the timing, location, and number of many contacts. But the central lesson remains: ancient humans were not sealed worlds. The Denisovan discovery also changed the value of small things. A splinter of bone, a molar, sediment from a cave floor, a protein preserved inside enamel or jaw tissue, these became potential witnesses. The ground did not need to give up a complete skeleton to speak. This is one of the lesser-known revolutions of modern archaeology. Sediment itself can hold DNA from humans and animals that pass through a place. A layer of earth can reveal presence even when no visible bone is found. Proteins can survive where DNA fails, allowing scientists to test fossils once considered too degraded or ambiguous. The archive of the past expanded from objects one could easily see to traces that require laboratories, contamination controls, sequencing machines, and careful statistical comparison. Yet this new power brought new caution. Ancient DNA is fragile. It can be contaminated by modern handlers. It can move in complex ways through sediments. It can degrade unevenly. Its survival depends on temperature, chemistry, moisture, and time. A genetic signal must be dated, checked, replicated, and interpreted with care. It does not remove uncertainty. It changes the kinds of uncertainty researchers must face. A genome can reveal ancestry with stunning clarity, but it may not tell where a person lived for most of their life, what language they used, what their group called itself, or how they understood outsiders. DNA is not a diary. It is a record of inheritance, powerful and partial. This distinction matters because ancient DNA can seduce the imagination. It feels exact, almost final, as if a genome is the truth beneath all other evidence. But the human past is not made of genes alone. A person is also tools, habits, food, landscape, care, memory, social belonging, and learned skill. Denisovans cannot be reduced to genetic percentages any more than a city can be reduced to the chemical composition of its bricks. What survives in the record suggests relationships and movements, but the lived world still requires archaeology, climate science, geology, comparative anatomy, and cautious imagination. The strongest picture comes when many kinds of evidence meet without pretending to say more than they can. Still, DNA did something extraordinary for the forgotten age before civilization. It gave back depth to people who had almost vanished. It showed that the absence of bones is not the same as the absence of history. It allowed scientists to identify a population whose existence had been missed, then detect its legacy in living people across distant regions. It also forced older fossils to be reconsidered. Teeth and jaws from Asia that once seemed merely puzzling could now be examined under a new possibility. Some may turn out to be Denisovan-related, some may not. Some may belong to unknown groups still waiting for a method strong enough to name them. The evidence remains incomplete, but incompleteness now feels less like a wall and more like a frontier. The Denisovans also changed the emotional scale of human origins. They showed that the deep past contains people who can be real without being visible in the old way. A complete skull gives the comfort of a face. DNA gives a different kind of intimacy. It says that a person once lived, inherited from ancestors, belonged to a population, and left traces in descendants. It can reveal that a vanished group met another group not as an abstract category, but closely enough for children to carry both histories. It can prove connection where archaeology alone might have seen separation. In this sense, ancient DNA turned human origins into a story not only of forms, but of relationships. And it widened the unknown. Each discovery makes the past richer, but also more crowded with unanswered questions. If Denisovans were hidden until the 21st century, what other populations remain hidden? How many human groups lived in regions where DNA rarely survives? How many left no fossils yet found? How many contributed small fragments to later people that have not been recognized? How many were absorbed so completely that their distinct shape can no longer be separated? The Denisovan revelation does not close the mystery of the forgotten age. It proves the mystery is deeper than earlier evidence allowed. That may be the lasting transformation. The story of humanity is no longer only the story of the fossils we can line up under glass. It is also the story of vanished populations detected in molecules, of cave dust that remembers footsteps, of living genomes that carry lost meetings, of old bones reinterpreted because one fragment changed the question. Before civilization, humans were already part of a world of movement, mixture, adaptation, and disappearance. Denisovan DNA did not merely add one new name to that world, it changed the light by which the whole world is seen. By the time the Denisovan evidence is gathered into one view, the forgotten age before civilization no longer looks like a waiting room before the real human story begins. It looks instead like one of the longest and most important human worlds ever lived, a world whose people carried survival across distances of time that make kingdoms seem brief. For roughly 100,000 years before farming became widespread, before towns hardened into cities, before temples rose over river valleys, humans and human relatives lived through transformations so large that later history can barely compare. Ice advanced and withdrew. Coastlines moved outward and then disappeared beneath the sea. Forests came and went. Grasslands opened. Animals shifted their ranges. Some human groups expanded, others retreated. Some met and mixed. Some vanished without descendants. Some vanished as separate peoples, but left something behind inside those who continued. The Denisovans stand near the center of that hidden world not because they were the only mystery, but because they reveal the scale of what was missing. They were unknown until a small fragment in a cave forced science to admit that the map of humanity had been incomplete. They had no city to announce them. They had no written name. Their bones were so few that their face remains uncertain. Yet their existence now changes the meaning of human identity. To be human is not to belong to one clean, isolated line. It is to come from a braided past, where populations separated, adapted, met again, exchanged genes, and sometimes disappeared into one another. Civilization, when it finally comes, does not erase that older inheritance. The first farmers are not new creatures standing apart from deep time. The builders of early villages, the keepers of grain, the makers of pottery, the herders, the monument builders, the people who eventually produce writing and law and kingship, all descend from bodies already shaped by older movements. Long before the first city wall, humans had crossed deserts, mountains, forests, coastlines, and ice margins. Long before formal trade, they had carried stone, memory, techniques, and inherited adaptations across landscapes. Long before written history, they had encountered other kinds of humans and absorbed pieces of those meetings into the future. This is where the popular question about why nothing happened for so long begins to lose its force. Something was always happening. It simply did not always happen in forms that later civilization knows how to admire. A stone tool tradition can last a long time, not because minds are empty, but because the technique works. A mobile life can persist not because people fail to invent settlement, but because mobility is the correct answer to an unstable world. A society can leave no buildings because buildings are not useful to its way of life. A people can appear quiet in the record because their materials decay, their camps are brief, their coasts are drowned, and their knowledge lives in memory rather than masonry. The evidence remains incomplete, but what survives suggests long experimentation, adaptation, and resilience rather than a frozen humanity. The absence of a lost Pleistocene empire does not make the age less mysterious. It makes the real mystery more powerful. The great question is not why there are no skyscrapers buried beneath Ice Age sediment. Mainstream archaeology gives good reasons to doubt such claims. Dense cities and industrial systems would leave broad, durable traces. The deeper question is how much complexity can exist without looking like civilization at all. How many roots were known and forgotten? How many languages, or language-like systems, vanished without a sound? How many tool traditions, seasonal gatherings, kinship rules, plant uses, animal stories, and sacred landscapes disappeared because they were carried in minds and bodies rather than carved into stone? The Forgotten Age may not hide a missing Atlantis, but it certainly hides missing worlds. Denisovans make that loss intimate. They show that entire human populations can fall below the threshold of memory. For tens of thousands of years, no one knew they had existed. Modern people walked the earth carrying fragments of Denisovan ancestry without knowing the source. The Tibetan high-altitude adaptation did its quiet work without announcing its ancient origin. Papuan and other Oceanian genomes preserved traces of archaic encounters without a story attached to them. The body remembered what culture had forgotten. That is one of the most haunting features of deep human time. Memory does not always remain where we expect it. Sometimes it is not in myth or monument, but in breath, blood, and inherited chemistry. The Denisovan story also reminds us that disappearance is not always failure. It is tempting to arrange history as winners and losers, with Homo sapiens as the winner and everyone else as failed experiments. But this is too crude for the evidence. Denisovans survived across immense time. Neanderthals did too. Other archaic humans endured in their own worlds. They were not failed modern humans. They were successful ancient humans, adapted to conditions that changed around them. Their eventual disappearance may have come from climate stress, demographic vulnerability, competition, interbreeding, and chance, not from any single flaw. No single explanation fully accounts for their ending, and it may be that there was no one ending, only many local endings that later merged into silence. From the viewpoint of civilization, a city feels permanent and a cave camp feels temporary. From the viewpoint of deep time, both are fragile. Cities fall, languages vanish, rivers shift away from capitals, written records burn or are never made, even stone monuments erode. The Denisovans ask modern people to widen the scale. A group that leaves only a tooth and a genome may still matter. A people without architecture may still change the future. A forgotten encounter beside some vanished route may echo longer than a dynasty. The ancient world before civilization was not a blank page waiting for writing. It was already full of human consequence. In the end, the 100,000 years before civilization are not a preface. They are the foundation beneath every later story. They are the age in which humans learned again and again how to survive uncertainty, how to belong to landscapes that would not stay still, how to carry knowledge without books, how to meet the unfamiliar, and how to continue after loss. The Denisovans are one of the clearest signs that the foundation is deeper and stranger than once believed. They remain unfinished in science, unfinished in imagination, unfinished in the record, a cave in Siberia, a jaw from a high plateau, a trace in living genomes, a breath in thin air. These are not enough to restore them completely, but they are enough to prove that before civilization, humanity was already vast. And so the story does not end with a monument, because the Denisovans left none that we can name. It ends, for now, with an opening. Beneath the known past lies another past, older, quieter, and more difficult to see. Every new method reaches into it a little farther. Every fragment asks a larger question. Every absence becomes less empty. The forgotten age remains not because nothing happened there, but because so much happened in forms time is skilled at destroying, somewhere under sediment. Beneath forests, inside caves, under drowned coastlines, and within the genomes of living people, the old human world is still present, waiting not to be invented, but to be recognized. The night settles gently over the older world. The cave mouth darkens. The plateau wind softens into distance. The long rivers of Asia move under moonlight, some still flowing where they once flowed, others buried, redirected, or lost beneath the sea. Nothing in the landscape speaks plainly. The stones do not explain whose hands shaped them. The bones do not tell every name. The sediments keep their patience. They hold what they can and surrender only fragments. Somewhere in that immense quiet, the Denisovans remain partly beyond reach. They are not restored as a people in full colour. Their faces are still uncertain. Their voices are gone. Their stories have no surviving words, yet they no longer belong to emptiness. A small bone in a Siberian cave, a great jaw from the edge of the Tibetan Plateau, large teeth, ancient proteins, cave dust, and living genomes have gathered around them like faint stars returning one by one to a dark sky. The picture is incomplete, but it is no longer blank. And perhaps that is the truest shape of deep history. It does not always return as a finished story. Sometimes it returns as a sign, a pressure, a pattern that says there was more here than anyone knew. Before civilization, before writing, before the long noise of kings and empires, people lived through ages so vast that their days are almost impossible to imagine. They woke to cold. They watched animals move across valleys. They carried fire. They protected the young. They learned the moods of rivers and mountains. They crossed paths with other humans, and some of those meetings travelled farther than memory. The Denisovans disappeared as a visible people, but disappearance is not always the same as nothingness. Their world ended in one form and continued in another. It continued in inherited breath, in hidden ancestry, in small biological echoes carried through bodies that would one day build villages, cities, ships, temples, libraries, and laboratories capable of finding them again. The past, it turns out, is not only behind us, some of it is folded quietly within us. So the forgotten age remains, wide and dim, not empty, not primitive, not simple, but deep. It is a landscape of vanished paths and surviving traces, of human lives too old for memory yet too important to ignore. And in the last image, the cave is still there in the mountain dark, holding its cold air and ancient dust, while beyond it the wind moves across the old earth, carrying no names, only time,